Alrighty. Hello, everybody. My name is Parker Brown, and my partner Noah Liebers here. We worked on a project covering the Python library MyPy. This is the optional static typing checker. So for an overview of what we're going to cover, we're going to go over the introduction of what MyPy actually is, walk through some of the examples of how to apply MyPy, as well as use the tool and some basic examples. And then we're going to go over some technical details, evaluation of the program from Tivi's point, and then related work as well as the conclusion. So to introduce the problem, static typing or statically typed languages like C or Java or other languages like that often involve variables being checked at compile time. Python has the option for declaring variable types, but is dynamically typed otherwise. When working on large projects with lots of developers, this can often be an issue to use dynamic typing, as it can be confusing for some people that don't understand the code or are not familiar with the language. Instead of just using dynamically typed or static type, and statically typed just makes it easier across the board to have a sort of style sheet to make sure that everybody understands the same code and that there is a good formula for everyone to follow so the code stays consistent throughout. So for MyPy is a tool that checks Python optional static typing. MyPy can be installed through the command line using the command pip install MyPy. It's just a standard Python library. By default, MyPy will not check any functions classes without type declarations, and MyPy can understand local type interfaces, but will need help when declaring global variables. MyPy also uses library stubs for checking code interaction with different library modules. For the next demo, we have an insertion sort. So we have a type of a list int, as well as the list int output that is expected. For the simple insertion sort, we have our output. So for the first run, our expected output is here, has a success with no issues found in one source file. Then we insert this new array. We have an error that pops up, which is expected. As the array here, this actually just is our counter example, just presenting that issue. So for the technical details and the high-level introduction for MyPy, every time you run MyPy on a Python file, there's a general flow of execution and common passes that the tool makes. There's the entry point, the build manager, Python parser, semantic analyzer, and the type checker. For the entry point, parsing configuration file is what this performs. Build manager coordinates the build. Python parser builds abstract syntax trees and converts it to a MyPy specified parsec tree. Semantic Analyzer binds names to definitions and performs consistency checks, and the type checker types checks the program and performs type interference.
All right, and then moving on to more in-depth technical details, starting with the Python parser. Again, this step creates a MyPy AST or parse tree. You can see an example of that on the right for a pretty simple example. But if this was more complex, say hundreds or thousands of lines of code, this would be a giant AST. And this is just a collection of nodes linked together based on Python syntax. And at this step, there isn't many consistency checks performed. So obviously incorrect code could get through this pass. And then this AST is passed on to the Semantic Analyzer. So then the Semantic Analyzer starts binding these variable names to definitions and begins performing consistency checks from the AST that it received in the Python parser. There's kind of two main modules, the semanal and the typeanal. And then each variable name can only be binded to a single type within a scope, so within a function or a class scope. This step also modifies the AST based on these things and passes it to the type checker. So the type checker receives that AST that was modified by the Semantic Analyzer, and this begins performing some of the main logic of whether a program has type errors. So it's going to take that AST and generate a map from AST expressions to types. So if you look on the right, we have kind of a sample, and that expression, MyPy needs to generate 5 sub-expressions and infer their types in order to infer that overall expression type. And then this also utilizes meet and join operations to determine the compatibility between some of these types. So kind of getting into the limitations of MyPy. Firstly, MyPy could not throw a flag even when there is incorrect code. So down below we have this simple function that's adding two arguments to a string and an int. And obviously there's something wrong with this code because it's directly adding a string and an integer together. But as we mentioned before, MyPy essentially ignores unannotated code. So you would need to add type declarations to the argument types and to the return type in order for MyPy to check this and throw a type error. And then I'm going to live demo some of this, but another limitation is that MyPy cannot infer the type of empty collections. So initially, if we just have a list that's declared to an empty list, and we run MyPy on it, it'll actually throw an error because it is unable to infer what this list contains for obvious reasons, and actually give us a hint how to fix this, which you can see here. And that will fix the error. But another way to fix this error is actually having some type of variable appended to that list immediately after it is declared. And if you run this again, it is able to infer that this is a list of integers because of that append. Another thing we'll get into of limitations is that MyPy struggles with redeclaring a variable within a single scope, so a function or class. We'll go back to PyCharm, and if initially we just have this function that has some variable declared to an integer and then redeclared to a string, and we run MyPy on it, it'll throw an error because, as we mentioned before, you can only have one type binded to that variable. So another fix to this, if you ever had a situation like this in your code, would just to be declare as any type initially, and then from there MyPy will never complain because any types are compatible with anything. And then also part of our research was running this tool MyPy on a real-world project. So we chose Pitivi, which is a open source video editing software, mainly written in Python. And the nice thing about this project is that it already has type declarations implemented in a lot of its code. So the initial run of MyPy we ran on all the Python files, and it took about 45 seconds. And the nice thing about MyPy is it also supports a remote cache. So it saves some of the results from previous runs. So that improved the following runs to about 3 to 4 seconds. And we actually did find a few type errors in our runs. And you can see here on the right, this is just some of the examples that we found. And all of them are actually related to this empty collection thing that we talked about earlier. So the fix for this, we just have to actually declare type here under each collection. And then Pitivi actually does utilize pre-commit hooks to run MyPy on some of the files with every commit. And then some of the related work, we found a few tools that are pretty similar to MyPy, PyType and PyWrite being the first two. And both these tools perform type checking, but both of them use inferences without unannotated code to do their type checking, where MyPy will basically just ignore code without annotations. The last tool we found was Parser, which was created by Facebook and Instagram developers. And the difference between this and MyPy is that it actually ships with another tool called Parser, and that does static analysis, specifically taint analysis for security measures. Just to conclude, our project was based on MyPy, which is an optional static type checker for Python. And the problem this tool is trying to solve is that large Python projects can become confusing to many developers without static type declarations, and manually checking these declarations would take a long time. So we talked about MyPy and its important passes as it's actually running through the tool. And then we ran MyPy on a real-world project in Pitivi, and we discussed some of the similarities and differences between these 3 other tools that we found that are similar to MyPy. Alright, thank you for listening to our presentation.